Today, the world runs on fossil fuels. Despite decades of renewable energy development, coal, oil, and natural gas still account for over 80% of our global energy mix. This figure is staggering, considering the urgent climate crisis facing the planet. This deep dependence is not an accident. It is the culmination of centuries of history and the very foundation upon which the modern global economy was constructed. Our story begins not with the internal combustion engine, but in ancient times, where early civilizations used coal for basic heating and rudimentary metalwork. However, the true transformation began with the Industrial Revolution in the 18th century. Coal was the revolutionary fuel that powered the invention of the steam engine. Suddenly, human effort was amplified exponentially. Coal-fired power drove new factories, allowing for mass production, creating dense industrial cities, and fundamentally revolutionizing global transport through steamships and, crucially, the railroad network. Coal rapidly became synonymous with progress, development, and national power. It fueled the rapid urbanization of the Western world and changed the social structure forever, creating a global economy based on constant growth and industrial output. By the mid-19th century, coal was the undisputed king of energy, providing the heat and power for the majority of the world's burgeoning industries. But the formidable reign of coal was soon challenged by a liquid gold, oil. The discovery and subsequent mass production of petroleum in the late 19th century ushered in the 20th century, which is rightly called the Age of Oil. Oil was inherently more energy-dense, easier to transport, and far better suited for the new personal and mechanized technologies being developed. It provided the essential fuel for modern transportation: the car, the truck, the airplane, and the vast global shipping network that links continents. Oil quickly became the lifeblood of industrial expansion, also giving rise to the complex petrochemical industry responsible for plastics, fertilizers, and countless modern materials that define daily life. This pervasive reliance necessitated the construction of vast, complex global infrastructures, pipelines, immense refineries, endless gas stations, and interconnected highways that now crisscross virtually every developed nation. Furthermore, the strategic importance of oil quickly intertwined itself with global geopolitics, becoming a source of both immense wealth and persistent international conflict, dictating foreign policy for over a century. Alongside oil, natural gas grew substantially in prominence. Initially often seen as a mere byproduct of oil extraction, natural gas is primarily composed of methane. It holds the advantage of being the cleanest burning fossil fuel, making it highly desirable for electricity generation and residential heating applications. Its widespread adoption was accelerated by new technologies like hydraulic fracturing or fracking, which unlocked massive reserves previously inaccessible. Natural gas now serves as a key transitional fuel, frequently replacing high-polluting coal plants in many regions globally. Yet, it comes with its own environmental footprint, most notably through methane leakage, a potent greenhouse gas, and the localized environmental controversies associated with its extraction methods. This historical narrative is one of unparalleled human development and explosive economic growth. The consistent availability of cheap, dense energy lifted billions out of poverty and gave us the interconnected, technology-rich world we recognize today. But this foundation, built entirely on carbon, carries a heavy and escalating cost. The immense scale of emissions from these fuels, from coal smokestacks to vehicle exhausts, has dangerously destabilized the Earth's climate system. The very engine of our modern prosperity is simultaneously threatening our collective future. The journey from coal-fired steam engines to modern gas turbines is an incredible story of human ingenuity, but it is also the undeniable story of how we created our current environmental crisis. Understanding this history is the crucial first step in pivoting toward a sustainable future. The narrative of progress built on fossil fuels, which we explored in our first part, is shadowed by an immense escalating cost, a debt owed to the planet. While coal, oil, and gas delivered unprecedented economic expansion, they simultaneously unleashed forces that threatened the stability of the natural world and human civilization itself. The consequences manifest immediately in localized health crises and globally in the profound disruption of the Earth's climate system. The most visible consequence is often air pollution. When we burn fossil fuels, particularly coal and diesel, we release a cocktail of pollutants: sulfur dioxide, nitrogen oxides, and particulate matter. These are the components of smog, a toxic blanket that covers major urban centers, leading to millions of premature deaths annually from respiratory illnesses, heart disease, and strokes. Beyond the air we breathe, the extraction and transport of these fuels have left their scars on landscapes and water bodies. From vast strip mining operations that destroy ecosystems to catastrophic oil spills that devastate marine life and coastal communities for decades. However, the most formidable and far-reaching impact is climate change, driven primarily by the release of greenhouse gases, chiefly carbon dioxide. For millions of years, the Earth's carbon cycle maintained a delicate balance. The industrial age fundamentally disrupted this. By digging up ancient stored carbon, the fossil fuels, and releasing it into the atmosphere, we intensified the natural greenhouse effect. Carbon dioxide acts like a blanket, allowing the sun's energy in but preventing excess heat from radiating back into space, thereby raising the planet's average temperature. This phenomenon is amplified by methane, a greenhouse gas significantly more potent than CO2 over the short term, often released during the extraction and transport of natural gas. The physical evidence of this global warming is now overwhelming and undeniable. We see it in the rapid disappearance of the Arctic sea ice and the dramatic retreat of glaciers across all continents. These frozen reservoirs of fresh water are melting at an accelerated rate, contributing directly to a rise in global sea levels. Coastal cities, low-lying islands, and major deltas are already facing increased flooding and are preparing for an existential threat. Furthermore, the oceans, which absorb much of the excess heat and carbon dioxide, are suffering from thermal expansion and ocean acidification, destroying coral reefs and threatening the marine food webs that support billions of people. The destabilization of the climate system means that the weather itself becomes more extreme and volatile. We are witnessing an increase in the frequency and intensity of natural disasters globally. Prolonged record-breaking heat waves stress human infrastructure and public health. Intense droughts lead to widespread agricultural failure and exacerbate the risk of massive, uncontrollable wildfires. Conversely, warmer oceans fuel more powerful and devastating tropical storms, and changes in precipitation patterns cause catastrophic floods in regions unprepared for such volumes of water. These events displace populations, create climate refugees, and threaten global food security, demonstrating that the cost of carbon is paid not just environmentally, but in human suffering. The era of cheap, easy energy is over. Our historical reliance on fossil fuels has brought us to a critical junction, a planetary emergency that demands an immediate and decisive shift away from the carbon-based economy. The question is no longer if we must transition, but how fast we can embrace cleaner, sustainable alternatives. Our previous videos established the historic reliance on fossil fuels and the severe environmental price we are paying. Now, we turn to the solution: the Great Energy Transition, a necessary and urgent global movement away from carbon and towards sustainable, clean energy sources. This transition is not merely a theoretical ideal. It is a rapid, technological, and economic shift that is already reshaping the world. At the forefront of this revolution are solar and wind power. Driven by relentless technological innovation and falling costs, these energy sources are now often the cheapest form of new electricity generation globally. Massive solar photovoltaic farms are sprouting up in sunny regions, while wind turbines, both onshore and in vast offshore arrays, harness the power of atmospheric currents. They offer a simple, profound advantage. They are limitless, domestically available, and produce electricity without the carbon emissions inherent in burning fuels. This growth is critical, but it introduces a challenge: intermittency. The sun doesn't always shine, and the wind doesn't always blow. This challenge is being met by revolutionary advancements in energy storage and grid management. Large-scale battery storage facilities, often lithium-ion and growing in capacity, are now being integrated into power grids. These batteries store excess power generated during peak production times, a sunny afternoon for example, and release it when demand is high or production is low. Furthermore, the development of smart grids utilizes digital communication technology to intelligently manage the flow of electricity, optimizing distribution, reducing waste, and seamlessly integrating distributed renewable sources like rooftop solar panels. This creates a resilient, decentralized, and much cleaner energy system. However, the energy transition must reach beyond the power sector. We must decarbonize transportation and heavy industry, sectors historically most dependent on oil and gas. In transportation, the shift to electric vehicles, EVs, is gaining unstoppable momentum, replacing internal combustion engines in cars, buses, and even short-haul trucking. For long-distance shipping, aviation, and heavy industries like steel, cement, and fertilizer production, new solutions are being deployed. Green hydrogen, produced by using renewable electricity to split water, is emerging as a zero-emission fuel source and industrial feedstock that can tackle these hard-to-abate sectors. The shift to clean energy brings significant geopolitical and economic advantages. It offers energy independence, liberating nations from volatile global oil markets and supply chain vulnerabilities. More importantly, the transition is a massive engine for economic growth, generating millions of new high-skilled green jobs in manufacturing, installation, maintenance, and research. Global cooperation, exemplified by ambitious international climate agreements, provides the necessary framework for this worldwide effort. This collective action is driven by a shared understanding. The historical pathway of fossil fuel dependence is unsustainable. The transition to clean, renewable energy is the definitive pathway to securing both a stable climate and a prosperous, healthier future for the generations to come. If you found this exploration into our energy future insightful, please subscribe to the channel and give this video a like.